I recently reported that summertime growth of tagged silicoidea was significantly greater in 2019 than it was in 2018 and 2021. An audience member asked if perhaps food was more plentiful during the summer of greatest growth, but I had to admit I didn't know. I promised to start monitoring food available to my mussels in the future. And what, you ask, do mussels eat? The jury's still out on that question, but conventional wisdom suggests that phytoplankton form the bulk of mussels' diet. Now, a guy could laboriously count individual algae cells, but another perfectly good way to get a handle on phytoplankton concentrations is to measure the amount of chlorophyll present in lake water. Today we're going to grab some water from the lake and figure out how much mussel food is in it. All this starts with a beat-up old cooler.
Actually, that's how I've been doing most of my water samples lately. She burns less gas, for one thing. A lot of fun. Less gas, more fun. Always good. So we'll get her out here into a little deeper water, and then I'll fool around with the motor for a while. It usually takes, after a week or so, it usually takes a few pulls, one or two choice cuss words to get her to run. Another nice calm day here, just a little bit of a breeze. Nothing too crazy. If we have to, I'll row the whole way. I've done it before. It's no big deal. It just takes about, half hour or so to 45 minutes maybe to get down to the sample locations. But we'll see here if we can get the motor running.
So there's a 10-mile-an-hour speed limit on Crooked Lake. So consequently, this little over a mile trip from my dock down to the mussel bed takes around about 15 minutes or so.
The job at hand is to get the appropriate jar out of here, the one for the mussel bed. It's already labeled. And I'm going to dip it over the side here, somewhere along the line. I got the idea that a guy should rinse the sample container 3 times and then take the sample on the 4th. So I just kind of plunged it in there and dumped it out, plunged it in again, etc. Filled it up. Oh, I should probably show you. I left a little bit of space in the top for air, but it's mostly full. And we'll close this up and put it in the cooler with the ice. Dry off a little bit before I touch my camera.
The orange arrow shows where the first sample was taken, just beyond the drop-off near the mussel bed. Next, I slipped through the channel and dipped out some water from the middle of Little Crooked. That's the red arrow. The blue arrow shows my dock, where I gathered the 3rd water sample.
Well, back to the house, and I'm gonna walk you through what happens in the lab after the samples are collected. Starting a new worksheet here, chlorophyll worksheet.
First one's going to be the sample we'll process was from near the mussel bed, and let's see, we'll put the date in here, which is the 14th of June, 2022. Collected that sample down there at the mussel bed at 10 minutes after 10. And first thing I'm going to do is make sure my pH meter is still working properly. So got this little handheld pH meter, which I've calibrated before, and we'll just make sure, yeah, we're getting a pH of 7.0, so that looks fine. Get out a sample bottle here. Let's see, we want a mussel bed. It's always good to have a towel when you're doing this kind of stuff. I usually have 2 or 3 laying around, one over my shoulder and one elsewhere, so I don't slop too much water around. And I'll just go ahead and take the pH of this sample, and I'll go ahead and do the other 2 here in a minute off camera. Usually it takes a little bit for this to settle down and give me a stable reading. A couple of years ago I was presented at a conference, and one of the participants asked me what the pH of the water was at the mussel bed. I'm like, I don't know. Just haven't done that yet. So here's a good opportunity to check that. So it's 8.3 today. 8.3. And we'll write that down here on our sheet. 8.3. Okay. I'll turn the camera off. Do the other 2. All right. So the actual filtering. Of course, we want to get our jar labeled. Jars. And I like to use these little flat bottom museum jars, kind of a small size. They have a nice tight fitting lid. They're made for holding stuff like alcohol and formaldehyde with little critters in them for years and years. So they're really rugged. They have a good seal. And so that's what I'm going to use to ultimately put my filtered sample in. So we're going to do the mussel bed first. Alright, so we got a label that says mussel bed in 95% ETOH. And we'll put that on a jar here. And it's also helpful to label the lid for later purposes, just to kind of keep track of things better. So I'm gonna weigh this apparatus later on, probably tomorrow or Saturday. So we're just going to put mussel bed here on the top. So we don't get the lid mixed up with a different jar when time comes to take the lid off and take things out and weigh them. Okay, so we got that done, and we can set that aside. We'll do the other ones later.
Okay, so my I don't have enough hands. A little essential piece of equipment is this other empty jar. It's got approximate volumes written on the side, and we're going to use that here to weigh out our fluid that we're going to filter. So again, here's my mussel bed sample. Gently shake that up a little bit. It's going to get kind of noisy here in a minute because I'm going to be using a vacuum cleaner to get my vacuum Here's my apparatus. It's all 1 gallon shop vac that I repurposed, and the hose is hooked up to this weird looking thing here. It's a 5 gallon bucket with a lid pierced with 3 fittings, bulkhead fittings. Down inside I have another littler bucket. I think it's a 3 gallon bucket, which just kind of helps to support the side of the bigger bucket when it wants to pull in when I pull a vacuum on it. Yeah, so I'm going to pull the vacuum in through here. So there's a valve on it that allows me to regulate how much air gets pulled out. Then I've got another one here that allows me to regulate how much air goes in to the bucket. Right now it's all the way open. And then this last one is going to get the filter put on top of it. All right, so that looks like this, in case I forget. It's a Millipore filter, which I borrowed from the micro lab, Jenny's permission, and I'll show you how to assemble that in a minute. But that's going to go here on top of this fitting, and then I can regulate how much air gets pulled through there here. So I've got 3 different ways to regulate airflow, which is kind of nice. Okay. So the first thing I need to do here is get my filter ready. And this comes apart, so it unscrews, just like that. And then I've got some filter discs, and these are rated for 3 microns, so pretty fine pore size, and that filters out most everything in the water. A red blood cell is around 7 or 8 microns, human red blood cell. So most algae and stuff that I'm interested in, mussels are going to be eaten, are that big or a little bigger. So technically, one of the ways to get this to stick good is to squirt a little bit of water on it. It doesn't really matter how much at this point, because this water is reverse osmosis water, essentially really high quality water, distilled water. So there's nothing in it that's going to cause any problems. And then take this and gently put that on there. It's kind of important to make sure we don't cross thread this so it goes on straight. You don't have to tighten it real tight, but snug. Looks like a pretty good fit. Now I'm going to stick that on top of my bucket over here. So let's see if I can get this off of here without messing things up too bad. Yeah, so there we are. So there's my Millipore filter perched atop the apparatus. Okay, so just about ready to filter here. We've got our filter disc in place. I'm going to jot down the time here that we're starting. So filtration time on my sheet is going to be 11:40 a.m. I'll put a little dash to give me so I can put the end time in a little bit. And then total volume filtered. That's where we're going to use this this area here to record the weight of the water that goes in to the filter. And the way I've figured out how to do this is to pour some water in this empty vessel over here I showed you a little bit ago, up to the just a little bit shy of the 500 ml line. And it doesn't have to be exactly on it. In fact, it's good if it's a little bit less. Dry the outside of that a little bit. Put it in on our fancy triple beam balance. Which is something that people generally associate with high school chemistry labs that are underfunded. But I've had this one a long time, and it works great. I don't have to worry about whether or not the power works or it's getting a little water spilled on it or whatever, because it's entirely mechanical. There's no electronics at all. And it also measures to the nearest 1/10 of a gram. It gives me a really good precision rather than worrying about trying to pour this in a graduated cylinder and having it be accurate to only, maybe the nearest 10 mLs or whatnot. This gives me really good precision. And as you may recall, 1 cubic centimeter is equal to 1 milliliter. And if you have pure water at reasonable temperature, volume of that 1 ml is, or the weight of that 1 ml is 1 gram. So this is a different way of measuring volume of water. I'm doing it by weight. So on this first go, I'm going to write down 530, 531.5 grams. I'll put a little dash mark there to remind me to weigh it again here in a minute. Okay, so it's going to get noisy. My apologies. But that's how it goes. I keep that thing running for the whole go, but it's too loud for you to actually hear what I'm saying. So I poured my fluid in there. I set my empty back on the scale, and now I'm going to weigh that again to get the tare weight. Looks like it's going to be about 80 grams. And this is going to include, of course, any little drops or whatever that are still stuck to the inside of the vessel. So the difference will represent how much water actually got poured out. Right? So 80, 84 on the nose, so 84.0 is the weight of the empty vessel. Now I'm going to go ahead and do that again. Let's see here what our gross weight is for our second one. Looks like about 500 and I'm going to say 30. $534.7. 534.7. Okay. So I'm going to zoom in a little bit here, and that way you can actually watch me pour it through the filter. So again, apologies for the noise. So it doesn't really take all that long to pull that through there. All right, so it's quiet again. I got all that run through, and here you can see this is filled in here. So I've got the gross minus the tare weight, and I'll do the subtraction later and add them all up, and that'll tell me how much water total volume was filtered. And I finished that at the actual filtration part at 5 minutes to 12, so that's 11:55. So it took about what 15 minutes or so to do that, and there's still some more to come. Number of filter discs, 1. Approximate volume of solvent, I'll get to that in a minute. What I need to do now is disassemble my apparatus. So I'll just take it off of the fitting and unscrew the little funnel part on the top. Set that aside. And you can actually see that filter has got a green cast to it. It was originally white, just like that edge that was underneath the plastic rim of the funnel. So that's the algae that we just filtered out, sitting there on top of the filter disc. And the goal now is to get the chlorophyll out of that algae and into alcohol, so that we'll be able to read it later in the spectrophotometer. Okay, so here's where the labeled jar comes into play. There we are. One for the mussel bed. And we'll open that up. I'll take these forceps here and just kind of gently get underneath the edge and whip that in there, upside down. So it's like that, just sitting on the bottom, upside down. And again, we'll just set all this stuff aside, get it out of the way a little bit. And I've got some 95% denatured alcohol here, ethanol. And I've fooled around with the volumes on this quite a bit. And I finally got it down to where I like the amount that I'm using. So I'm going to pull out 8 milliliters of ethanol with this pipette. And we'll transfer that over here. Squirt it in our jar. Get the last little drop out. There we are. And put the lid on that stinky thing and the lid on that stinky thing. Make sure I get that down nice and tight because ethanol evaporates pretty quickly. And there it is in the bottom of that jar. Okay, so it's going to sit there nice and flat for between 48 and 72 hours. Let that extract at room temperature, and then we'll pick it up at a later date. I'll show you what to do with it after that. Let's see, anything else I need to do here? Oh, approximate volume of solvent. I'm going to put 8.0 milliliters. Yeah, so right there. And then all the rest of this stuff is going to happen in a couple days. So I'm going to go ahead and do my other 2 samples from Little Crooked Lake and from out here at the dock off camera. It's a couple days later, and I'm going to transfer the fluid from these museum jars into vials. So first, before I do that, I'm going to weigh the museum jar with the fluid and filter and stuff in it. So that's 98.23. .23 grams. That's the gross weight. And then I'm going to take a Pasteur pipette and draw that off, that fluid. Oops, almost forgot. First thing I want to do is put a cotton ball into this little funnel. It's made out of the funnel's made out of the end of a 60 cc plastic syringe that I cut off with a hacksaw. So now we can transfer that over. And the reason I'm doing this with the cotton ball is to get the little particles, the little floaties and stuff out of the fluid before it goes into the vial. Another way to do this would be to centrifuge it, but I don't have a centrifuge right here at the moment, and this works pretty well. So it's also quicker. It doesn't matter, like however you want to get your floaties out, it'll work. This is how I've chosen to do it. Okay, so we got that in there. And not very much of it makes it through, honestly, until you persuade it a little bit by putting the plunger back in and shoving that down kind of gently. maybe a little bit more than gently. Try to get the last few drops out. And there we go. Put the lid back on here. And there's some fluid from the mussel bed extraction. Another thing I'm going to do is take the lids off of these jars. So mussel bed jar, and I got the lid labeled here. I'm just going to take these two and sort of set them like that. So I've got the lid on the bottom and the jar on the top with the jar open to the air. And I'm going to leave that set aside for overnight. And then tomorrow I'll come back and weigh those again after the alcohol and the little bit of water is evaporated out of the jar and the filter. And what that'll do is it'll allow me to fill in another part of my spreadsheet or worksheet here that'll give me the dry weight of the filter and the empty weight of the vial. And when I subtract those two things from the gross weight, that'll give me the weight of the solvent that was in there, taking the chlorophyll out of the filter and dissolving it in the solvent. So I'm pretty well done for that, and then the next step will be to measure the absorbance of the chlorophyll that's in that fluid that's in each of these 3 vials here. Okay, so what I have here is my spectrophotometer has been warming up for about 10 minutes. I've got a blank here that's from this vial. That's 95% ethanol in that cuvette. My spike is known concentration of chlorophyll in that second cuvette. My third cuvette is my unknown. This one happens to be from Little Crooked. And just like any other spectrophotometer, you've got to standardize this thing before you use it. So 0 checks out. Absorbance of my blank, and then we'll run the spike. Okay, so that's 0.200. That's about right. And then we do that, I do that as a kind of a quality control measure, just to make sure that I'm getting values that seem reasonable. Things didn't get too crazy since the last time I used the instrument. And there's my absorbance for Little Crooked Lake. It's pretty quick once you got everything all set up. And we'll turn that off. So next we'll measure the dry weight of the filter and that's 0.54. And the weight of the empty jar, including the lid, .32. We'll do the rest of them off camera.
In case you missed it in that last little sequence, what I did here was added up the amount of water that went through the filter. It wound up being 1,348.5 grams. You divide that by 1,000, that gives you 1.3485 kilograms. And assuming that density of water is 1, that gives us 1.3485 liters of water by weight. So now we'll figure out how much solvent we had. So we take the gross weight of 98.23, subtract from that 0.54 weight of the filter and the empty weight of the vial, and that gives us a weight of solvent of 7.37 grams. And when you multiply that times the density of 95% ethanol, 0.78, gives you a volume of solvent of 9.44 or whatever milliliters of solvent. Now you might notice that's a little bit more than what we said we put in. You saw me measure out 8.0 milliliters of ethanol, and that discrepancy, that difference, is the amount of moisture that was in the filter. So that also counts toward this value. So to figure out how much chlorophyll was extracted from the filter, we take the absorbance value that came from the spectrophotometer. In this case was 0.025, absorbance at 65 nanometers, and multiply that times the regression coefficient, which came from a standard curve that I came up with some time ago. And that gives us this 0.002825 value for the milligrams of chlorophyll per milliliter of solvent. And we bring down the value from above for the volume of solvent by weight, that 9.448 value, multiply that, and that gives us the amount of chlorophyll that was extracted. So this value here, 0.02669. So we're almost done. And we pull down our volume of water that was filtered from above. The arrow is kind of hidden there behind the calculator, and that's what we divide by. So we divide 0.02669, etc., by the total volume filtered, and that gives us this final value here for the concentration of chlorophyll in the lake. And we're going to round that, so in this case we can declare that the amount of chlorophyll in our sample of lake water from off the mussel bed was 0.020 milligrams of chlorophyll per liter. Some remarks are in order on why I modified standard methods of chlorophyll analysis for this study. First is my selection of ethanol rather than acetone as my solvent. Most folks who extract chlorophyll for spectrophotometric work use acetone, but in my current situation, I prefer not to use an organic solvent that is both quite volatile and potentially explosive, and alcohol is a reasonable alternative that works just fine. Chlorophyll comes in several varieties, A, B, C1, C2, etc. There's also auxiliary pigments that some algae contain. So, workers often read absorbance values at 2, sometimes 3 wavelengths to discriminate between the various photosynthetic pigments. I've chosen to read at just the 1 wavelength to simplify and streamline the process. Since my goal is to compare mussel food concentrations summer to summer over many years, 1 wavelength seems adequate. The long-term nature of this project dictates that the methods be simple, inexpensive, and easy. That'll let me continue to collect chlorophyll data as I age and hopefully hand it off to a younger colleague in the future.